Our project will focus on petrochemical industry wastewater treatment with the title of Activated Sludge Treatment Process Control. This is our team members, in which it consists of 6 students taking CEB3032 Chemical Engineering Lab 3. Presentation will include the introduction, problem statement and objective, process control system, challenge in process control, recommendation, and finally the conclusion of the project.
Starting off with the introduction, so what is an activated sludge system? Activated sludge system is a biological treatment process which uses the suspended growth of microorganisms in order to remove the biodegradable organic matter (BOD) and suspended solids in a wastewater. The steps involving in the process including mixing of primary effluent with the retained activated sludge, forming a mixed liquor, aeration of mixed liquor for a specific time inside the aeration tank, growth of organisms into solids by feeding of organic matter, and lastly, the separation of solids with the wastewater in the settling tank. These 4 steps will keep repeating and removing the excess solids and organisms from the system. For the problem statement, generation of wastewater tainted with hazardous compounds such as sulfides and ammonia have results in the contamination of soils, water, and air, which would impact not only the individual ecosystem but also towards the global implications. Thus, to mitigate this issue, our project will utilize the activated sludge process control system to treat the contaminants in the wastewater. To ensure a good efficiency, factors such as aeration, pH and temperature of water, nutrients in the water, and food to organisms ratio must be monitored and kept at optimum value using the PI fuzzy combinations controller. Therefore, the objectives of this project are to propose an appropriate activated sludge system equipped with PI controller and to optimize the activated sludge system through parameter tuning using fuzzy logic.
The activated sludge unit ASU consists of 2 anaerobic reactors followed by 2 anosmic reactors and 3 aerobic reactors, which is responsible to remove phosphate and nitrogenous bacteria from the effluent. Besides ASU, primary and secondary sedimentation unit, anaerobic digestion unit, thickener, storage, and dewatering unit make up the activated sludge waste system. Overall, the combinations of PI fuzzy controller is chosen as the control system. You might wonder, what is PI fuzzy controller? Fuzzy PI controllers have 2 input and 1 output, which can provide more control diversity than a traditional PI controller because of its many inputs. Based on literature, fuzzy controllers act as the most advanced control which are commonly used in processing units in wastewater treatment plant. The advantage of PI fuzzy controller is it can utilize non-linear control techniques and allow us to take into account the minor and error tendency alone. Here is how the PI fuzzy controller works. Cascade configuration is utilized in this approach. In aeration tank 6, the SO6 set point for ammonia control is manipulated by fuzzy controllers by triggering and the signal and sent to the valve to reduce the amount of dissolved oxygen entering the stream when the measured concentration is below the set point. Next, the set point of SO6 in aeration tank 6 is regulated by controlling the rates of airflow in reactors 5, 6, and 7 by PI controller when there is error set point value detected either below or above 2 mgO2 per liter. One thing to take note here is the output of the fuzzy controller is the set put for the PI controller. The type of control system used is a closed-loop feedback process control system which generates negative feedback.
Hi, my name is Etul Palend and I'll do the discussion about the results and analysis. In the results and analysis, we have 3 graphs that represent the performance between PI controller, low-level PI controller, PI MPC, and PI fuzzy and their comparison between them. In this graph, it can be seen that PI fuzzy controller has the least fluctuating response and the highest concentration of ammonia at all times, and we can predict that it's more efficient for the activated sludge process. For this graph, we can also see that PI controller has the least fluctuation response and the highest concentration of phosphorus. For the comparison of the average production, we can see that PI fuzzy possesses higher efficiency in the removal of effluents, which is closer to zero waste initiative.
Moving on to critical analysis on environmental and chemical engineering element. First of all, environmental protection is a priority of economic and social growth to have a clean, healthy environment that does not limit the potential for future generations to prosper. Next, water, which is the most essential element for life on Earth, is used in the manufacturing, processing, washing, diluting, sealing, or transportation of a product. Water is also needed by smelting plant, petrol refineries, and companies that manufacture chemical, food, and petrol products. The quality and volume of industrial effluent can vary substantially depending on the industry producing it. It may or may not contain treatment-resistant compound or may not be highly biodegradable. This industrial effluent will totally comprise 1 or more contaminants such as fat, oil, and greases, chemical, detergent, heavy metal rinse, sediment, and food waste. The biological water treatment method, also known as the conventional method, is a common and widely used treatment method that is the most effective way to reduce the organic content of dilute organic waste, considering its limitation on the process. It considers biodegradation, bleaching by taking the aid of several microorganisms. Since microorganisms in activated sludge are the primary contributor to pollutant removal, selecting effective bacteria will aid in improving wastewater treatment plant performance. This system enhances the naturally occurring process of microbial decomposition to break down industrial wastewater toxins and remove them. Lastly, in chemical engineering element, by installing proportional integral PI with fuzzy controller, the wastewater facility may now use models to understand processes, monitor and optimize wastewater treatment plant, particularly in activated sludge process. This type of controller has been used to ensure that a non-linear input-output static configuration can be changed according to the designer mind. The PI with a fuzzy controller can have many inputs as it can provide more control, diversity and act as the most advanced controller. As a result, the activated sludge system can operate at peak efficiency. Furthermore, if the activated sludge system fails, the water quality that returns to the ocean, river and lake will suffer, endangering aquatic life due to the toxicity and harmful pollutant in the water.
The challenges for the process control is first, wastewater sludge disposal, where the excess sludge production is the hard part of control in this process. Although in an aerobic process, an operational problem such as sludge bulking might occur. This will demand another treatment stage that require high operating costs. Next, this process controls needs an optimized dissolved oxygen level, where the concentration must be sufficient. Due to the different speed of concentration changes, the value of dissolved oxygen will be inconsistent and lead to decrement of concentration. This will worsen the treatment and rise the turbidity. However, there are some ways recommended to solve the issue on the process control. First, using aerobic granular sludge where its presence in system will lower the oxygen demand for nitrification as well as lower the rate of decomposition and will decrease the amount of sludge. Next is by using the slow aminium feedback. This type of feedback is better than fast aminium feedback since the aminium sensor can be replaced after the post-sedimentation without affecting the performance of controller. This will result in better measurement of dissolved oxygen and less maintenance.
To conclude, the two objectives are achieved as the system finally used the PI fuzzy controller in manipulating the dissolved oxygen entering the stream. Also, it is chosen as it has the least fluctuating response and averagely highest concentration of ammonia, as well as it provides the best response within the concentration limit at 2 mg per liter. Thus, it indicates that this is the best controller that can be chosen in this plant, as it also can ensure the activated sludge system always remove more contaminants and moving towards a zero-wave initiative. The challenge is identified by having the wastewater sludge disposal and optimized DO level. Thus, the recommendations are done to overcome those challenges by having aerobic granular sludge and slow ammonium feedback.